react with the metals to give hydrogen gas and the salt. The corresponding metal salt is obtained, and we also obtain hydrogen gas. And how do we test the hydrogen gas?
When it burns with a pop song.
Yeah,
It burns with a pop song.
yeah, it burns with the pop sound. So acids and bases, they react with metals to produce hydrogen gas, and the test for the hydrogen gas is hydrogen burns with the popping sound. So this is an indication that the gas that is produced is hydrogen gas. Metals. See, so how do, if we consider any acid, so let's have, you can consider HCl, H2SO4, ethanoic acid, any of the acids. So if you have HCl and if you react it with the metal sodium, so you will be getting the salt sodium chloride and hydrogen gas will be. If you react H2SO4 with metal sodium, you will be getting Na2SO4. Can anyone name this compound? Na2SO4.
Sodium sulfate.
Okay. So you get here sodium sulfate and hydrogen gas. If you have CH3COOH, it reacts with sodium. So what is expected? What we will get here?
NaOH.
NaOH.
No.
CH3COONA.
Yeah, we will be getting here the salt, which is CH3COONA. So this is the salt, and we will obtain hydrogen gas. Since this is acid, it is ethanoic acid. So when ethanoic acid reacts with sodium, it produces salt. Okay. So you have CH3COONA plus hydrogen gas. So in all the cases, we observe here a hydrogen gas is produced. Whenever a metal reacts with acid, it produces hydrogen gas. Now, do all metals react with the same extent? Do all metals react to the same extent?
No, sir.
Like here we have used sodium. No. So we use different metals. Here we have used sodium. If suppose we use aluminium, so again, if I use aluminium, the results will be the same. The results will be same, but the rate of reaction will change. Some of the metals they may react faster, and some of the metals may react slower. So if you have the reaction with low reactive metals, so the reactions will be slow. If you have the reaction with high reactive metals, so the reaction will be fast. Got it? So the reaction of metals with the correspond 1 minute. Okay. So if you have the reaction with highly reactive metals, so it will be a vigorous and fast reactions. So anyways, all the metals, they react with acids to produce hydrogen gas. Is there any metal which won't react with acids to produce hydrogen gases?
Nitric.
Nitric. Okay. So one of the examples, if you have nitric acid, which is HNO3, if you take nitric acid and if you react this nitric acid with sodium or any metal, if you react any metal with nitric acid, you are not expected to get here hydrogen gas. You will be getting here, you will get the salt NaNO3 you may get, but you will also get here water because of you may get NaNO3, you may get NaNO2 also. So because of such a, since this reaction, in this reaction nitric acid, it is a strong oxidizing agent. So it's a strong oxidizing agent, and hence it oxidizes the hydrogen which is produced. So whatever hydrogen is produced during this reaction, that hydrogen is oxidized to water. So you will not be getting hydrogen if you react a metal with nitric acid. And if the metal is less reactive than hydrogen, if you have a metal that is less reactive than hydrogen, then also you will not be getting then also you will not get salt plus hydrogen. Got it? So if there are metals which are less reactive than hydrogen, so you will not be getting the desired results. Understood this? Reaction of acids with metals. If we look up for the bases, so if you have reaction of base with metals, if you take any base, suppose if you have sodium hydroxide, and if sodium hydroxide being a base reacts with a metal, not sodium hydroxide, let's say we have zinc hydroxide. We have a base zinc hydroxide and it reacts with the metal sodium. So zinc hydroxide, it is an amphoteric hydroxide. Amphoteric means it shows sometimes acidic behavior and sometimes it can show basic behavior also. So zinc hydroxide, it reacts with sodium to give sodium zincate, Na2ZnO2. So sodium zincate, which is a salt is produced along with hydrogen gas. So a few metals can react with bases to form salt and hydrogen gas, but not all the metals. Okay, and not with all the bases. Only the bases which are amphoteric in nature and the metals which are highly reactive. So you will obtain the same results as we obtained with the case of acids. As we observed that acids react with metals to form salt and hydrogen gas. The same results we expected over here also. Got it? Yes, understood?
Yes.
Yes, sir.
Yes, sir.
Yes,
Okay, so we have done the reaction of, yes. The next one is metal carbonates and metal hydrogen carbonates. How do they react with acids? Next we have here reaction of and hydrogen carbonates. So reaction of metal carbonates and hydrogen carbonates with acids. You see, when I say metal carbonate, carbonate is CO3. Carbonate, it is CO3. So if you have any metal, a metal carbonate reacting with acid, a metal carbonate reacts with acid to form salt plus, now whatever hydrogen is used up here, whatever hydrogen is supposed to be produced. Okay, so the hydrogen is obtained from the acid part. So it will give us along with the salt, it will give us carbon dioxide and water. So these are the two products which will be produced along with the salt. For example, if you have Na2CO3, sodium carbonate, let us take the salt CaCO3, calcium carbonate. So these metal carbonates, when react with acids, HCl or H2SO4, you can take any acid. So when the metal carbonate react with acid, it gives us the salt. So here the salt will be obtained as NaCl, and we will get water. Along with water, we will also get carbon dioxide gas. Okay. So what test will the gas give? If you suppose you collect the gas that is produced during this reaction, so how you will test the gas? How you will test the gas? Ionija, Moksha, Pranaya.
So which gas is being tested? Carbon dioxide.
Which gas is being produced?
Carbon dioxide.
Yeah.
We can do the lime water.
Okay. So carbon dioxide. Okay. So all of you write down the reaction. So here we see that we obtain the salt. Here the salt is sodium chloride, water, and we obtain carbon dioxide gas. So how can we test the carbon dioxide gas?
Sir, it will turn lime water milky.
It will not turn lime water milky. So can you write down the reaction?
Yes, sir.
Okay, so all of you write down the reaction. Ionija, have you written the reaction?
Yes, sir.
Okay. So can you show it? Just turn on your camera and show.
Sir, could you once again repeat the question, sir?
You have to write down the reaction for the testing of carbon dioxide gas.
Okay, sir.
All of you write down the reaction for testing of carbon dioxide. Complete this second reaction. And also balance the first reaction. Yeah, so who all have written the reaction? I'll be checking each one's reaction now. Okay, so now it's your turn. Let me
Sir,
see the
could you once
reactions.
again share that, sir?
All of you who have written.
Sir, you once again could you share that, sir? I was
Uh,
writing the second question, sir.
Okay. So Sumukh, you can send it to as a direct message to me through WhatsApp. If your laptop is not working, okay, you can rejoin. Sumukh, you can rejoin. You understood what you have to write here? You have to write, you have to complete this reaction, balance this first reaction, complete the second reaction, and write down the test reaction. These three things should be there. First one is to be balanced. Second one is to be completed and balanced. And last you have to write the test reaction.
Sir, completed, sir.
Okay, okay. Okay, so just okay, Aryan, are you showing? Who is showing? Okay, just one minute. Uh, just 1 minute. Hold it there. Okay. The second one is also done. And where is the test reaction? Where is the test reaction?
That I'm writing, sir. Right.
Yeah, write down the test reaction also. Okay. Write down the test reaction.
Sir,
Yeah,
I have
Siddharth, have you done?
Sir, I have also done.
Okay, show it. Okay, show Ionija. Okay, I'm looking for Ionija. Show Ionija. Plus carbon dioxide with calcium carbonate plus. Okay, the second one is an excess of carbon dioxide. Fine. And the two test reactions, two NSUs. Okay. Yeah, thank you, Ionija. All are correct. Siddharth, you can show now. You have first one, Na2CO3 plus HCl. No, it's not. The first reaction is not balanced. You are also supposed to balance the reaction. And second one is also not balanced. The third one is incomplete. The third one. Do it.
Can I
Do
show
it
it?
again.
Completed, sir.
Okay, show it.
Sir, wrote the third
Sir,
reaction,
can I
sir.
show it now?
Yeah. Kashvi, have you done?
Yes, sir.
You just show it. Aryan, just hold. So NCl, 2 NaCl, 2 NaCl, 2. Twice. Okay, Kashvi, write down what will appear as a milky color. Which substance will appear as milky color? Write that also.
Sir, I have done.
Yeah, Shubhan, show it. Okay, Pranaya. Pranaya, you have given the reaction, but it's not balanced.
So the first one.
Balance the reaction. Okay, Shubhansh. Okay, I think now everyone has done. I should show you the answer now.
Ma'am, sir.
Yes,
Sir, can I also show
the
it now?
last one. Okay, okay, thank you. Shubhansh.
Sir, Abhinav.
Okay, okay, Abhinav. Okay, I'm showing it now. Now I'm showing the answers. You can match it. Okay. It will take a long time if I look up now. So if I balance this reaction, I need to balance sodium. See, in during the balancing, I told you that you first balance the metal. So here the metal you have two atoms of sodium. So here also you should make two atoms of sodium. So we observe that all the metals are balanced. Now we balance the non-metals. So here you have one chlorine, here you have two chlorine. So balance the chlorine. Now the reaction is balanced. Okay. Oxygen and hydrogen. Check for the carbon. Carbon is already balanced. Check for oxygen, it's balanced. Check for hydrogen, it's balanced. For the second reaction, you have calcium carbonate plus HCl. So you will be getting calcium chloride as the salt, which is CaCl2, and you will get water and carbon dioxide. So here you will get 2 HCl. The reaction is balanced. For the test reaction, you will be writing calcium hydroxide. You take lime water. So lime water has the formula calcium hydroxide. And if through the lime water, you pass carbon dioxide gas, you will get calcium carbonate, which will be milky in color. So it will be milky white in color. CaCO3, milky white in color. And water will be there. If you pass excess of carbon dioxide through it, then you will get calcium hydrogen carbonate, which will be soluble. So the milkiness will disappear. Okay. Now balance this reaction. You have NaHCO3, sodium hydrogen carbonate, when reacts with sulfuric acid. Write down, complete the reaction. Sodium hydrogen carbonate, NaHCO3, reacting with sulfuric acid, H2SO4. So what will be the product? What product we get here?
NaSO4 plus.
Is the formula correct? NaSO4.
Na2SO4 plus
the
H2O plus CO2.
Okay. We'll get here Na2SO4, sodium sulfate, and water, and carbon dioxide gas will be produced. Now we can balance this reaction. So we need to add here 2 NaHCO3. So now is it balanced? Is the reaction balanced?
No, sir.
Just check. No.
So
So
we have
where
to
should we?
add
Yeah.
2 before H2, I guess, because here we have 4 H.
Yes, sir. Sir, we have 10 oxygen molecules in the right side, left side.
Okay.
So we
And
should
here
have.
how many? Here how
Sir,
many?
we have 8.
8.
No,
So should
7.
we? Okay, so don't go balancing by that way. See, while balancing a reaction, always remember the technique. First, balance the metal, then balance the non-metal, and once you have balanced the non-metal, then you balance, once you balance all the metals and non-metals, then you balance oxygen and hydrogen. So oxygen and hydrogen, they are balanced at the end. When you are balancing the non-metal, you will balance all the non-metals except oxygen and hydrogen. So if you observe, carbon is unbalanced. Right? So if you balance carbon, to balance carbon, you should put here 2. And now you see everything is balanced. Is everything balanced now?
Sir.
Yes. So this is a specific reaction which we use, the reaction of sodium hydrogen carbonate with sulfuric acid to produce carbon dioxide gas, water, and sodium sulfate. So this is a specific reaction which you use in the soda ash fire extinguisher. Soda acid fire extinguisher, not soda ash. It's soda acid fire extinguisher. So if you use soda acid fire extinguisher, where we are using sodium carbonate and sulfuric acid. So when you plug out the sulfuric acid inside inside the cylinder, it gets mixed up with the sodium hydrogen carbonate that is placed in the cylinder, which creates a lot of carbon dioxide gas, and the carbon dioxide gas can be pumped, can it builds up the pressure inside the gas, and if you open up the nozzle, so the carbon dioxide gas will blow away and it will put the fire off. Okay, so soda acid fire extinguisher, it takes the use of this reaction.
Sir,
Yes,
sir, in the right hand side, H2O, there are only two molecules of hydrogen. But in the right side, there are four.
okay, so should we write here 2 now?
Yes, sir.
Okay, now everything balanced.
Yes, sir.
Check for oxygen also.
Yes, sir.
Okay. Okay, so this was the reaction of metal carbonates and metal hydrogen carbonates with acids to produce salt and carbon dioxide gas and water. Okay. Next is last part is how do acids and bases react with each other. So what specific name is given to the reaction of acids with bases?
Neutralization.
Yes, what specific name is given to the
Neutralization.
reaction of which reaction?
Neutralization.
Neutralization reaction. Very good. So we call it neutralization reaction. In the neutralization reaction, we have the reaction of an acid with a base. Acids react with the base to form salt and water. So you can take any acid reacting with any base. It forms salt, NaCl, and water, H2O is formed. So any salt can be taken which will react with the base to form salt and water. This specific reactions are called as neutralization reaction. And we have the formation of salts from them and water. Okay, a reaction of metal oxides with acids. Okay, can you answer these questions? Let's try to answer, then we'll end up. Why should curd and sour substances not be kept in brass and copper?
Sir, acid reacts with these metals, no, sir. So then it will be poisonous, like for curd and sour substances.
Yes, it will eat up the metal surface. It will eat up the metal. It will make the food it will make the curd poisonous. Also, the metal surface will get corroded. Then, which gas is usually liberated when an acid reacts with a metal?
Hydro.
Yes, hydrogen gas. Okay,
Sir.
just do this last one. Metal compound A react with dilute hydrofluoric acid to produce effervescence. Effervescence means bubbling. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. So just we'll do this reaction and then we can. All of you write down this reaction. A metal compound A react with dilute hydrochloric acid to produce effervescence. So effervescence means a gas is being produced, and if I look up at the gas extinguishes the burning candle. So which gas should be produced here?
Carbon
Which gas is
dioxide.
produced? Carbon dioxide is produced here, and the salt is given. The salt is calcium chloride, CaCl2. Now, can you guess which acid was there?
CaCO3.
Which acid was there? Acid.
HCl.
HCl.
HCl. Okay. And the compound A.
Yeah.
What was compound A?
Calcium chloride.
Calcium.
Carbonate.
Calcium carbonate. Very good. So it was calcium carbonate which reacted with acid to form calcium chloride, carbon dioxide. Is there anything which is left out?
Water.
Water.
Water. And now can we balance this reaction now? To balance this, we must add here 2. So chlorine is balanced. Metal, that is calcium, is already balanced. Carbon is also balanced. Check for oxygen. Is oxygen balanced? Yes. So the reaction is balanced.
Yes, sir.
Okay. So bye all of you. Will meet again in our next class.
Thank you, sir. Bye, sir.
Okay.
Thank you, sir. Bye.
So bye.
Thank you.
Bye,
Sir.
sir.